I work at the Southwest Fisheries Center with Dave, both work for Lisa Balance and Nutritive Resources Division. I'm in control. Thank you. And I'm going to talk about aerial photogrammetry and how we can use that tool to ask questions about condition, health, and reproduction. Photogrammetry used to have a very, very short definition. Now it's gotten longer, and it includes sort of all that's involved in taking photographs and how you can extract information not only about how many things you're looking at, but what their sizes and shapes are. And I'm going to talk about sort of the technology of photography, what we've done, because it's different than what you do with handheld photography from small boats. And then I want to talk about photographic images and what kind of information you can get out of them. Now, we've talked a lot about individual identification, but there's more information in a photograph than just recognizing individuals. I mean, it's pretty easy to tell on the left-hand side. You can tell me from my wife and from Steve, but clearly, Steve is bigger than we are. And the photograph captures that information. So photographs are also capturing information about size. And if you look at the other panel, there's a couple of ladies that are in an advanced reproductive state. Gabby is about 1 week from having her baby, and Claire is 1 week after having hers. And you can infer information about where they are reproductively based on their shape. And the same sort of thing can be done with animals in the wild. Wrong direction. So we started doing this back in the 1970s, just like RH. We started out doing film work. We're involved in research in the eastern part of the Pacific, so we're dealing with animals in incredibly large aggregations, sometimes thousands of animals, and we need to have a way to photograph these animals from the air so we can calibrate observers' estimate of school size. And we stumbled upon these military reconnaissance cameras, which were just wonderful systems. They're the best that film can do. They shot 300-foot lengths of film, 5-inch format individual images, so that allowed us to cover a big chunk of ocean. And the other thing is that they had this FMC system, the System for Forward Image Motion Compensation. So what that would do is if you tell the camera how high you are and how fast you're going, the camera would move the film as it was taking the picture at the same speed the image was going through the camera. So it was just like you took every image when you were standing still. These were the best around for aerial photogrammetry work on marine animals up until the late 1990s. We started out doing counts from photographs. We found the images were so clear that we could also measure sizes of animals in addition to counting. But then the digital age came upon us, and for us, it created a really new challenge because they don't have chips that are 5 inches by 5 inches. You know, the biggest chips are 35mm chips that can move data very rapidly. So we were faced with the challenge of how do we deal with photographing big aggregations of animals with chips that are very, very small. One thing that John said rang true with me, you know, with individual ID work, working with very, very big populations is a problem. With this kind of sampling, actually, this is an advantage you have taking aerial photographs, because you can photograph animals from large populations and learn a lot about timing of reproduction and size of first reproduction, because you can get a big sample from a big population. Okay, so here we were. We're faced with the challenge of what do we do with the digital revolution upon us. We didn't shift to digital. I was kind of a holdout until Canon came out with the Mark II 1DS camera, and when I looked at the images from those cameras, they were clearly better than film. So once that happened, we took our step into the digital world. But how do we deal with the problem of large footprint that we need with a camera that has a chip the size of a 35mm frame? And also, what about forward image motion compensation? You know, as you're flying along, even at high shutter speeds, your image degrades because your plane is moving forward during that instant that the shutter's open. So this is the concept we came up with 3 cameras mounted together, and this is what it really looks like in practice. My team is out flying right now with a mount just like that one. It has 3 of the Canon 1DS Mark IIIs. We shoot 85mm fixed focal length lenses. The lenses that we use are the Zeiss lenses. We don't use the Canon lenses. The new Zeiss lenses are absolutely beautiful. And the mount is designed so that we can tell the mount how high we are, how fast we're going, and it'll rock the camera at the same speed that the water's going by. So again, every image we take, it's as if we're standing still. So it lets us collect images of really high resolution. Okay, now to something that we're doing right now. The team is out photographing gray whales right now off the coast. They're just about done passing southbound. There's a mix of pregnant females, cows with calves, and adults and juveniles. And some of these groups of animals can easily be categorized based on their shape. For instance, the animal on the panel on your left is a pregnant female. And it's a little bright in here, you can't see it too well, but she looks like a swimming shoebox. I mean, she is just so wide.
How am I doing?
Starting to have flashes. But you can see how wide she is. I mean, remember with gray whales, they feed in the Arctic and they swim all the way down here and then swim back. And then during this migration period of the time of the lagoons, they're really not feeding significantly. So if you're going to be successful at reproducing and you're a female gray whale, you got to be a fat girl. And she's a prime example. She's a nice big wide one. And then the other panel is a female that's just had her calf. And you can see she's still a very robust animal. And that's a little brand new calf. I think I'm shooting through him. Oh, there we go. Okay, and so I mentioned before, gray whales are capital breeders. They're a group of animals that invest in capital by feeding up in the lagoons. Then they swim down south here. So you can estimate condition of the population by looking at the relationship between length and width of animals. And we started asking this question back in 1997, and we published a paper in 2002. And what we did is we took out all the pregnant females, we took out all the females with calves, because those animals are anomalously wide. Then we just looked at the remainder of the animals, and we compared length and width relationships between southbound whales and northbound whales. So we've got maybe 45 days in that time period in which they're burning up energy and not eating. And we found that there was a significant difference in the relationship of length and width. The animals going north were skinnier. So that means that we can ask pretty detailed questions about condition of animals from aerial photographs. We were able to do this study from 97 through 2003, which very conveniently included the time period when we had those big strandings of gray whales in 1999 and 2000. These are data on the relationship between length and width for gray whales collected from 1997 to 2003. It bounces around a fair amount, but you can see those years that we had lots of strandings. Clearly, gray whales were significantly narrower. They were significantly skinnier during those years. We think we know what was the driver behind that. That was an environmental event in the Arctic. But what it demonstrates is that we can track changes in condition in the population without having to kill any animals or handle any animals. We're sampling this year. We were trying to sample, but we haven't had the money for it until now. IWC fortunately wants us to do this sample again, because what we want to ask is maybe once or twice. Now, every day that we fly around Catalina, we see grampus harassing gray whales on both sides of the island. We see it around Santa Rosa. It appears that grampus are just all over the place. And it's a nuisance for us because the whales aren't swimming flat and level when the grampus are all over. I just wanted to mention this because internationally, aerial photography is what I do and what I'm interested in. But there are places where you really can't use manned aircraft to collect the data you want to collect. And now these modern unmanned systems are really proving to be very, very valuable. These little multi-engine copters have the ability to hover, so it's very easy to hold them over a target. They, because they're not moving forward, the image isn't blurred at all, so you don't need image motion compensation systems. We got some funding from the Advanced Sampling Technology Group and NOAA to take a couple of these down to the Antarctic last year. And we did a couple of things. We wanted to see if we could replace ground counts for aggregations of penguins. Some of these aggregations are hundreds of thousands of animals. So can we go out and photograph these animals with these little flying copters and get data that are as good as you can get on the ground. And we did several counts over several colonies. We found that our counts from photographs were just as good and actually more precise than the counts that they made on the ground. This is just a little section of an image, but you can see the chicks so well that really you can almost count eyes and divide by 2. We also photographed Antarctic fur seals. This is a little piece of an image. Again, the question was, if you have big aggregations of fur seals, to count pups, it's a fairly invasive process. Can you do that remotely with no disturbance to the animals? This aircraft is just about 100 feet up. You can see one animal here who appears to be looking up at us, but none of the rest of them are paying much attention. But these are pups. I mean, my gosh, they're the easiest thing to count in the world. The other thing, colored tags based on where they were born, or what year they were tagged on. And these are really easily visible from the air, and also this animal has a little radio tag. It's about the size of your thumb, and it stands up really well. So I think there's a lot of potential here for a wide range of studies. It's a good way to take aerial photography offshore. For instance, the work John does, he could have one of these on his little boat, and he could get size and shape information in addition to all the photo ID data he collects. So we're out flying right now. This is just an example of what the images look like. The system is really working well, and we're really happy. Thank you.